Hi, welcome back to my channel. So, my name is Syafiqa Binti Rahim, and we are going to learn nuclear fission and nuclear fusion in 15 minutes. So, let us start. So, let us look here. Can you see the sun? Do you ever wonder how the sun gets its energy from? So, till now, we have studied a lot of sources of energy. So, today, we are going to learn the ultimate source of energy on Earth. This is a source by which the sun gets its energy. Thus, we are going to learn about nuclear energy. Are you excited? Yay! I'm excited too. So, let us move on. Do you know who this is? And have you ever seen this equation? So, this is Albert Einstein. We started to learn about this energy, which is nuclear energy, after Albert Einstein introduced to us an equation, which is E equal to mc square. This equation is actually linking two totally unrelated quantities, which is mass and energy. So the mass is represented by letter M and energy is represented by the letter E. This equation has established a vital link between mass and energy, that mass can be converted into energy and vice versa. So this process can be related to two reactions that we are going to learn today: nuclear fusion and nuclear fission. To understand both of these processes, which is nuclear fission and nuclear fusion, so first we have to recap on the structure of an atom, which looks like this. In the center, there is the atomic nucleus, that is to say, the thing that will split or that amalgamate with another nucleus. Atomic nucleus. So, nucleus contain of neutrons and protons. The protons are positively charged, meanwhile, the neutrons have no charge, hence they are neutral. Thus, the atomic nucleus as a whole is positively charged. Around the positively charged atomic nucleus is so-called electrons. So, electrons are whirring around like in a kind of cloud. They are negatively charged. So, let us move on to the first reaction, which is nuclear fission. In simpler words, nuclear fission means splitting of an atomic nuclei. This is the process by which energy is generated in nuclear power plant. The nucleus of heavy unstable nucleus splits into two lighter and stable nuclei. As we can see from this video, here, the atomic nucleus is hit by a single neutron that is flying around. The impact causes the atomic nucleus to split into two new nuclei, and of them takes part of the electrons with it, so that two new atoms are formed. In the case of some very large atoms, a few neutrons are additionally released. So let us look here. When the uranium atoms are split in a nuclear power plant, these usually involve the release of 3 neutrons, which can affect the next fission processes in a chain called chain reaction. And finally, the energy is released, and very much of it. That 1 kilogram of naturally occurring uranium has the energy of 12,000 liters of mineral oil or of almost 19,000 kilograms of hard coal. Wow, that is a lot. To look back here, do you ever wonder where the energy comes from and how come it has so much more than in the cases of other energy which carries such as oil and coal? So let us look back. Besides the neutrons, the atomic nucleus only consists of the positively charged protons. Now, equal charges repel each other, which is quite similar to the equal poles of two magnets. The fact that the protons in the atomic nucleus remain together is due to the so strong interaction, which is one of the four fundamental forces in the universe and by far the strongest. This force used to be called nuclear force or strong nuclear force, which acts like a strong rubber band that holds together the atomic nucleus with its proton, which we know do not really want to hang around so closely together when the impacting neutron forces the nucleus apart. So this is exactly the energy that has been stored in the rubber band that is released. To relate this process with the equations, we can say that the mass of two nuclei is actually slightly lighter, and we can say that the mass loss is actually converted to energy. So we can say that mass can be converted to energy. But then, one of the major problems that arises in the use of nuclear reactor is that the waste which is left out after the nuclear reactions, which is actually highly poisonous, and it also can cause cancer. Wow, that is very dangerous. Thus, these waste here need to be disposed at a far away place and as safe as possible from the community. Aside that, the power plant should be operated very safely as a slight error could cause explosion and it spread out of the radioactive nuclear waste into the surrounding. The most recent nuclear power plant accident took place in Fukushima, which occurred in April 2011. And fortunately, the good thing about the accident is that the casualties are minimal. But then the people who live in Fukushima are actually still struggling with the after effect of this accident. So this is the picture that occurred the nuclear accident at 3 Mile Island, which occurred in Pennsylvania. So the next picture is actually the after explosion of Chernobyl. And the next one is explosion that occurred in Fukushima. So if we somehow could make the nuclear power plant safer, and if we also somehow could find a better way to dispose this waste, then I can say that nuclear energy could power up the whole world. Next, we'll move on to the process of nuclear fusion. So, in a simpler way to explain nuclear fusion, it's actually exactly the other way around, where the atomic nuclei amalgamate and result of nuclear fusion that shine us from the sky is the energy that stars like the sun emit. Nuclear fusion presents actually a similar picture, but it can only work with small atoms like hydrogen, for example. The atomic nucleus of hydrogen consists of only one protons. If one now tries to force two of those protons together, these two would have to repel each other, which is due to their equal charge, just like a magnet. This force can be called as a Coulomb force. When the two protons come too closely together, a strong interaction can come into play again and make these two amalgamate into a new atomic nucleus. For example here, as in the case of the nuclear fusion on the Sun, it is in fact 4 hydrogen atoms, that mean 4 protons, that amalgamate to form a helium atom. But as helium atom only has room for 2 protons in its nucleus, the other 2 are released in a similar way to the excess neutrons upon the fission of uranium. And of course, these also involve the release of a lot of energy, even more than nuclear fission. From here, I can say that it would only take 1 gram of fuel, or the hydrogen isotopes, which is deuterium and tritium, to get as much as energy from 12,000 kilograms of hard coal. But then, since the process of speeding up the atomic nuclei require a lot of energy, of heat energy, to support the repulsion. So it is quite impossible to achieve on Earth. If we look here on the Sun, where there are 15 million degrees Celsius and a pressure of 200 million bar are necessary to amalgamate the hydrogen atoms, which mean that it cannot be achieved in controlled manner on Earth, as it requires a very high temperature and a very high pressure that need to be fulfilled. So now you have know how the sun got its energy, which is through the process of nuclear fusion. So before we end our video today, so can we have a quick test? So just as a recap from what we have learned just now. So the first question, what is the process describe 2 small nuclei combining into a large nucleus? Okay, so let us look at the keyword here. The keyword is 2 small nuclei combining into a larger nucleus. Okay, have you got the answer? Correct. The answer is nuclear fusion. Fusion. We are fusion. Okay, the next question. What is the process that is described by the splitting of a nucleus into smaller nuclei? Okay, so can you guess the keywords here? What? Correct. It is splitting. Splitting of a nucleus. So what is the answer? Yes, the answer is nuclear fission. Nuclear fission. So, thank you guys. I really hope that everyone could differentiate between these 2 processes, which are nuclear fission and nuclear fusion. And really hope that maybe one day one of you guys could create a safe nuclear power plant that could generate energy for the whole world. So let us meet again the next time and the next day. So let us love physics. Bye-bye.